friends, I am Pragyan. Welcome you all. Hope you all are keeping well. Today we will discuss the most exciting part of chemistry, that is chemical test to distinguish between the two pair of compounds. Why I have decided to take this video? Because many children make mistake. So let us have our fundamental clear so that we can write the correct answer. So let us start today. Now I have taken two compounds. One is sodium carbonate, another one is sodium sulfide. Here three there, that is why sodium sulfide. Here what to do? First of all we have to think what is the reagent you have to add. So every time decide which reagent you are taking. Both the sides it will be the same reagent should be taken. And while writing this chemical test, write this one in column wise so that easily you can compare. So here I am adding dilute HCl. You can write take HCl, otherwise H2SO4 also can be taken to it. We know that whenever acid is added to carbonate, here what type of gas evolves? Here evolves carbon dioxide. Here whenever we are adding HCl or H2SO4, what we are getting here? We are getting SO2 as the gas. So now instead of writing carbon dioxide evolve, instead of writing SO2 evolve, we have to write a chemical test to distinguish the carbon dioxide and sulfur dioxide gas, so that we can know this is a carbonate part from which carbon dioxide has come. It is a sulfide part from which sulfur dioxide has come. So here what to write? When HCl is added to Na2CO3, a colorless, odorless gas evolves which turns lime water milky. This word is important, you have to mention this. But it has no effect on acidified K2Cl2O7 solution or KMnO4 solution. Here it does not change this color, no change in color. Means no change in color. But here what happens? When HCl is added, SO2 gas releases. So we have to write the test for SO2. A colorless gas with a burning sulfur smell, means a suffocating odor smell gas comes out, which turns lime water milky. Both these sides will be lime water milky. But here what happens? It decolorizes acidified KMnO4 solution. Decolorizes means it turns colorless. If this KMnO4 solution turns pink to colorless. Or you can write this one, or you can write this one. Orange acidified K2Cl2O7 solution, it turns green. Okay. So next is FeSO4 and FeCl3. Means we are taking Fe2 plus distinction between Fe2 plus and Fe3 plus salt. Here whatever we have taken, let it be sulfate, let it be chloride, let it be nitrate, all these things will be different, but Fe3 plus, this one will be Fe2 plus. So what reagent have to take in? We have to add NaOH solution. Here we are adding NaOH solution. Here also we have to take NaOH solution. And here first of all we will put dropwise till excess, means in a test tube if you are taking FeSO4 solution, we have to add first of all few drops of NaOH. After that one we will see what happens, what changes occurs. After that one we will add more amount of NaOH solution. So what we see in the first case? We see a dirty green precipitate is formed here. Fe2 plus dirty green precipitate is formed, which is insoluble in excess of NaOH. More NaOH you are adding, then also this dirty green precipitate will not dissolve. But here in this case, when you are adding few drops of NaOH, then reddish brown color precipitate will be formed. When you are adding excess of NaOH, then this reddish brown precipitate will not dissolve. Okay, so this is the distinction. both the cases it will not dissolve, both the cases precipitate will be formed, but here in this case dirty green precipitate, here this one will be reddish brown precipitate. So next is zinc nitrate and lead nitrate. Okay, this is a common board question. Question usually comes distinguish between Zn2 plus and Pb2 plus, or question comes name a reagent which can be used to distinguish between Zn2 plus and Pb2 plus. This answer will be ammonium hydroxide. Okay, now let us see. Ammonium hydroxide reagent will take for both these sides. Now add ammonium hydroxide to this above salt solution zinc nitrate we will take. So first of all we will take it dropwise. What happens? When dropwise it is added, a gelatinous white precipitate will be formed. Gelatinous, what is that? White precipitate but little shiny in color. Gelatinous white precipitate is formed. But when we are adding excess of ammonium hydroxide, this white precipitate will dissolves and it gives a colorless solution. But what happens in this case? Lead nitrate, the same thing, ammonium hydroxide, it is added to it. Here it will give a chalky white precipitate. The difference is that here gelatinous white, here chalky white. But excess, when you are adding excess of ammonium hydroxide, this chalky white precipitate does not dissolve. It is insoluble white precipitate will be formed. What is the common mistake children they do it? They use sodium hydroxide and they write down that one, a gelatinous white precipitate will be formed, a chalky white precipitate will be formed. That one is wrong. Here we cannot use NaOH because both the salts are soluble in excess of NaOH. So you may ask why you take excess, dropwise small amount will take. But if you are taking sodium hydroxide, if it will be little concentrated also, they can dissolve. So better option to take ammonium hydroxide in this solution. So next is sodium chloride and sodium nitrate. Okay, so this one is another interesting. We will add the reagent silver nitrate solution. When silver nitrate solution is added to this sodium chloride solution, a cloudy white precipitate will be formed. What is the cloudy white precipitate? This is of silver chloride, but here I have to mention just for you understand, that is why only silver chloride I have written here. So you will write a cloudy white precipitate will be formed which is soluble in excess of. This part you have to write. This is must, you have to write. Otherwise if you are writing this much, you may lose marks, because this is not the many cloudy white precipitate are formed. But if that one will be soluble in ammonium hydroxide, then only this will be the clear distinction for chloride ion. Okay, so here it is a cloudy white precipitate is formed which is soluble in excess of ammonium hydroxide. Let us go for this sodium nitrate. Here also we have to add silver nitrate. One thing, see that one, here we have nitrate part, here we have nitrate part. So what will be our answer? No visible reaction takes place. So next is sodium hydroxide and ammonium hydroxide. Here let us add copper sulfide solution. First dropwise to it. We will see this one, a pale blue precipitate will be formed. Okay, but when this NaOH will be added to this pale blue precipitate, when excess of NaOH is added to, here we are putting dropwise, no? Now we will go for this excess of NaOH added to the pale blue precipitate. It does not dissolve, means it remains insoluble. Otherwise we can write blue precipitate remains. It is not soluble. But in case of ammonium hydroxide, we are adding copper sulfide solution. The same thing we are adding. A pale blue precipitate will be formed. Dropwise, no, that is why. Dropwise, a pale blue precipitate will be formed. But when excess of ammonium hydroxide will be added, the pale blue precipitate dissolves and a inky blue solution will be formed. In this case, it will dissolve and pale blue precipitate will turn to a solution. Next is ammonium sulfate and sodium sulfate. What should be the reagent? We are taking sodium hydroxide is the reagent. So add sodium hydroxide to the above salt solution. When sodium hydroxide is added, ammonium sulfate, then here ammonia gas evolves. Okay, so now we have to write the test for ammonia gas. So we have to write a colorless gas with a sharp pungent smell evolves. Then again we have, this is the physical test. Then we have to write the chemical test, which turns Nessler's reagent brown. Nessler's reagent original color is colorless. So it turns colorless to brown. Or also you can write, when a rod dipped with concentrated HCl brought near the gas means this gas, a dense white fumes are seen. This will be for ammonium sulfate. But in the sodium sulfate, the same reagent have to take sodium hydroxide take. Here, no such gas evolves. Okay, here sodium we have taken, here also sodium taken, here no such gas evolves.